Hello students, today we're talking about transformations of exponential and logarithmic functions. If you haven't already, I would highly suggest you go back and take a look at the video for transformations of functions because I'm going to be bringing that up to explain this. Alright, so your notes that you were able to print out are right underneath the video. But they are transformation of exponential and logarithmic functions. We're going to be talking about exponential first and then logarithmic second. You may recall the parent function for exponential is y equals b to the x, where b is any real number. In most cases, in this case, I'm going to be making b 2. So the base is going to be 2, and the exponent is going to be x. All right, so you may recall that a logarithmic function y equals 2 to the x has a asymptote at y equals 0. All an asymptote is a horizontal line, in this case, where the function gets closer and closer and closer. So as x goes out to infinity, the asymptote, the output, gets closer and closer to 0. You can see that in this table. Okay, we have -2, -1, so it's going out to the left. Our output, our y's, are getting smaller and smaller. Then on the right-hand side, as you go out to the right, our output is getting larger and larger. So here's the transformational equation. We have a in front, then x minus h and k. Just to bring your attention back to something that we know previously, if I write this equation right here, y equals a something like absolute value x minus h plus k. That's the transformational function of absolute value. You can see it's kind of similar to this. The a is out in front. Then you have inside you have the base, but next to the x you have x minus h and then k. Now you know that the a scales the function. If it's between 0 and 1, meaning it's a fraction, then the function increases at a gentler rate. If a is greater than 1, it will increase much faster. So a gentler rate would be something like this, and much faster would be something like this. Okay. Now, also, if a is negative, it'll be reflected on the x-axis. So it'll be going down like this. Okay, so I left that out. If h moves the function to the left or right. So if your h is positive, it moves to the right. If it's negative, it moves to the left. And k moves it up and down. So we have the same transformations that we did before. Going on here, here's a first example. We have y equals x, 2 to the x plus 3. Notice there's no h up here, so h is 0. That's just x plus 0. A is 1, since there's no number out in front of 2, so it's not going to be scaled. And k is 3. So the only thing this is doing is moving it up 3 units. So that's up 3 units. Okay? So we take our original parent function here that goes through 0, 1. That's important. This one doesn't go through 0, 0. And let's move that key point up 3 units. And now we have the same looking function. It's just transformed up 3 units. Now, the important thing to remember is the asymptote, which was y equals 0, is now up 3 units also. So the new asymptote is y equals 3. Now we can say that the asymptote, without even looking at the graph of an exponential function, is always going to be y equals k. Notice K was 3. I moved up 3 units. So my new asymptote is the horizontal line y equals 3. Okay. Now, how did I get this table? Well, you can plug and choose by hand, but I'm going to show you that you can actually get it on Desmos too. If I type in the new function, y equals 2, and then to the x plus 3, it gives me that right there, that new function. Also, if I type in y equals 3, just to highlight the asymptote there, that's the asymptote. So you can check the asymptote. Let's say I thought it was at 4. That's not it, right? 2, that's not it. But if I go to 3, that's definitely it. Okay, so you can always check the asymptote that way. Now, how do you make a table? Go up to this cogwheel, choose table, and here we have a table of 2 to the x plus 3. So every input I have, and I can change my inputs. Let's make x go out to the negative 6. There we go. Negative 6 is right there. So what does my function approach as I go out more negative? Negative 10. It looks like it approaches 3. So that's why I have a horizontal asymptote at 3, because my function output approaches 3 the more negative I go. I hope you understand that. If you don't, just ask me questions during class. All right, so there we go. Let's go on to the next example here. The next example, I have an h and a k. A is still 1, so it is not scaled. But h in this case is 2, because remember, h has the opposite of whatever you have in here. So because it's x minus 2, our h is actually positive 2. So that's 2 to the right, and this is 4 up. So I'm going to take my key point, which is, again, 0, 1. It's not 0, 0 for our exponential. 0, 1, I'm going to move it up 4 units, and then to the right 2 units. And here's my new function. I just draw the exact same thing, but with a key point at 2, 4, or 2, 5. Now, where is my asymptote? My asymptote is at y equals k. In this case, k was 4. So my new asymptote is at y equals 4. Again, if I want a table, all I have to do is go to Desmos here and put in the new equation, y equals 2. And I'm going to get up into the exponent. Remember how to do that? You go to the exponent here, and then inside the exponent, x minus 2, and then come down plus 4. And there's my new equation. Again, if I want to check out the asymptote, y equals 4, I just type that in, and here we go. Now, if I want a table, just go to this and hit table. And here's a table, and I could put in any value of x and get my appropriate value of y. Okay? Now we're going to go on to log, I think. Here we go, logarithmic. You may recall that our parent function for log is y equals log x. The transformation equation is y equals, again, you have the a in front of log. That's our scalar. And then we have x minus h plus k. Notice all these equations are pretty much the same. So a scales the function. Again, same scalar. H moves the function to the right or left. K moves the function up or down. And we have a new vertical asymptote. So it's a vertical asymptote this time at x equals h. In this case, x equals 0 is our vertical asymptote. So this function approaches 0 for the x and then goes out and ever so slightly increases over time. So it does go out to infinity, and it goes up to infinity slowly. So let's take a look at an example here. Here I have y equals log x plus 5. Let's pick out our a. Our a is 1 because there's no number out in front of log. That's an understood 1. Then we have h is negative 5. Remember, h has to be the opposite of whatever you have inside here. So since it's x plus 5, our h is negative 5. So that means I'm going to move left 5. And then I don't have any plus or minus anything over here, so that's k equals 0. So our new function, let's take our key point here, which is 1, 0. Not 0, 0, 1, 0. Move it to the left 5. Draw the new log function. So it looks the exact same as the other one. It's just moved to the left 5. Also important is our original asymptote, remember, was the vertical equation. Remember, vertical equations have x equals equations. X equals 0. That was our original. If I move that to the left 5, then it's going to be x equals negative 5. So we have a new vertical asymptote at x equals negative 5. All right, I hope that helps. And if you have any questions, just ask me during class. Bye.